All right. So welcome to part two of this video, page two, part two, same kind of thing. Let's talk about the progression from 0D to 1D. So the one thing I'm not going to do is write anything down. So please take note that I just kind of want to have a conversation with you guys, albeit a one-way conversation, because I think that's the best way we can discuss this. And the thing I don't want you to do is in any way just kind of copy down what I write and just reproduce that as if that was your thinking. That's not what this is about. That's not the kind of thinking I like in class, and out of you guys. You guys are better than that, frankly. So this is kind of have a conversation about how these progressions actually work, and I'll leave you guys to kind of think of it and kind of propose your own worded answer, okay? So let's talk about 0D and 1D. Remember, 0D is points, locations. 1D is a line, and lines extend in both directions towards infinity include a whole lot of points, more than just one or two. So this is what this progression is showing. So kind of consider like this is kind of like that thing where you have to kind of start talking to someone like they're a 6 year old and then progress upward until you're talking to them just like you would an adult, because that's what you're seeing here. So let's talk about how points become a line. So here you totally have like this one point, and if you kind of think about why it's important to start here, is because if you're talking to someone and saying, "Well, I have this line," the first thing they're going to ask you is, "Where? Where is this line you're talking about?" Right? And so that's kind of what you have going on in this panel. This point, the whole point of this point is to show you that you have a location. To tell someone like, okay, the line I'm talking about kind of starts right here, or at least here's a part of it, right? So this panel is really important because it shows location, which is what points are anyway, right? So here we added a second point to our first point, and so if you kind of think about the importance of this, well, if I just have like this one point and I say, well, I have this line and it's kind of around this one point, where do they go from there? Like, so, I mean, if I just said, well, I have this point here, it's really cool, and then, but I really want to make this a line, you're not really giving them anywhere to draw. Like, where do they go from here? Do they go this direction or that direction or that direction or that one or that one? It's really hard to tell because what you haven't given them is a direction or orientation, which is really what the second point does. So that first one gives you a location. The second one gives you an orientation. So now you can clearly see where the line's supposed to go. So now the job is to start identifying more points because 2 points will tell you where a line is located and how it's oriented, but it won't identify all the points yet. And so if you think about the key word for picking these points, the term here is collinear. So I'm just not going to pick like any old random point, like none of those actually apply to my line. I'm going to pick all the ones that appear in between and past the points that I've identified. So I first tell you where to look. I then tell you which direction the line's going to go. I start picking a whole bunch of points, and then once I pick them all, it'll basically end up being a solid line. That representation is going to be the one that actually we're going to use the most. But in the end, it's the one that shows you have infinite number of points. All right. So points to lines. Let's go to 1D to 2D, and you're going to see very similar thinking here too. So now that we have this line, location, orientation picked out, now we have to start weaving this together to get more than one point, or sorry, to get more than one line. In other words, we're going to need to cover pretty much like the entire plane with these lines. So what we're going to do is pick another line. So the key here is we're going to intersect our original. This is going to give us the second dimension past this distance. I'm sorry, length. It's going to give us like width or depth, however you want to think about it, because it's running in a non-collinear fashion. If it was collinear, it'd be like one on top of the other. That's no good. You don't want that. So moving on, we pick like another one. So this is now starting to identify all the points that we're going to have. Now, what's important to note here is you are seeing like these 3 points again. Oh, there we go. Okay, so we're starting to see like these 3 points again, and I don't know if you guys saw that because I think it kind of temporarily cut out. But you are seeing these 3 points. These points are the ones who actually define the plane. Like, so it's kind of like the point idea. Like, these tell you where to look. These lines that are kind of intersecting another, they're all coplanar. And so if I want to fill in the rest of the plane, like what I need to start doing is to pick more lines. And these lines all have to be coplanar to my original three, which is what you're seeing in this panel. So I pick more and more lines until the entire plane is fully defined and then it kind of just smooth it out. Like in the same way I totally smoothed out all those points to make a line here, I'm smoothing out all these crazy lines just to represent a plane here. Now again, please keep in mind that it's all supposed to be collinear. I'm sorry, excuse me, coplanar. Um, a flat surface that extends in all directions. So it's probably more accurate to represent the plane more like this. Okay? So let's continue. Let me make sure we saw that. Let's talk about 2D to 3D. So now we have this plane. You're going to see, again, a very similar kind of argument that we had for the previous one, where you start with one plane and you start to pick other planes that are non-coplanar, that are running in different directions. In the same way, the lines running in different directions define groups of points at the same time. That's what's going on here as well. Now we see we have more planes running in more directions. And then finally we have when you pick all the planes, then we just have like this nice solid surface. Uh, yeah, this nice solid surface that covers basically all 3D space. Okay, so again, I didn't want to write anything down there because I don't want you just to copy my words. But we did have a nice conversation, albeit one way, kind of about this. So you're welcome to kind of take that, absorb it, but try to make it your own. Like in the end, if I ask you this question on the test, it's going to have to be your kind of interpretation of what's going on. So certainly take a shot, write your best explanation. If you want me to critique it before the test, I totally will. You're just going to have to ask me to do that. So that's that page. I'll see you guys in part 3.